Solving Dante's canes. Now, the facts of the case are pretty much clear. There's a material cost for each cane of $32.50. There's the packaging cost for each cane of $12.75, and those two together represent the cost of goods sold for each cane. There's the idea that we're either going to buy or rent the cutting machine, and they have different fees. We have the kiosk rent versus the store rent. The depreciation period, which was an assumption on my part. The tax rate, which also was an assumption on my part. The spinner pay, which comes from the case. And the number of summer months, which was also an assumption on my part. Now, there's 4 decisions as laid out by the case. Whether or not he uses the kiosk or the storefront, whether or not he buys or rents the cutting machine, and whether or not he hires a sign spinner, and finally the price that he charges. Now, the way that this works is that the sign spinner can increase your quantity sold by 50%, but only if it's in front of a storefront, because you're not allowed to have a sign spinner in front of a kiosk because it clutters up the boardwalk. So this is a case where we needed to use the AND function inside of our if function. So my quantity equation looks like this. If and B1 equals 1 and B3 equals 1. If the location is storefront and we're hiring a sign spinner, then the quantity sold is the 75,000 divided by price times 1.5. We're increasing it by 50%. Else, it's 75,000 divided by B4. You can break this up into several pieces, but the fact remains the same, that you only increase the quantity if you have both the storefront and you have a sign spinner. And it wouldn't hurt to take this function and put it inside of a floor function so that we don't end up with any fractions. Now, the other way to do it would be, let's increase this by a couple of rows and say, so this quantity is the base quantity. And this quantity is only based on the equation 75,000 divided by price. And then we're going to have another quantity called increase. And this is only happens if the sign spinner is in front of the storefront. So equals if and B1 equals 1 and B3 equals 1. And if both of those things are true, then this should be equal to line B6 times 0.5. Otherwise, it should be equal to 0. And so the total quantity is equal to my base quantity plus the increase I get from having the sign spinner. So my number is the same. I just need to make sure that my equation refers to the total quantity instead of the base quantity. And the same thing for my references for my cost of goods sold. And we end up with the same answer, but for some, if you want to know, this makes it easier to understand. We have the equation from the case, 75,000 divided by B4. We have the decision to hire the sign spinner, which increases my quantity, and then we have the final one. And let's include this in a floor statement. All right. Now, moving forward, we have our cost of goods sold, which is equal to our total quantity times the sum of our material costs and our packaging costs, and our gross profit, which is the difference between our revenue and our cost of goods sold. Kiosk rent is equal to our kiosk rent times the summer months, but it's only if the kiosk rent is equal to, if the B1 is equal to 0. Now, this is a different kind of decision matrix. This basically is using the identity function of 1 and 0. If instead you want to use the if statement, it would be if B1 equals 0, comma, then we're going to use the kiosk rent, else we're going to use 0. And the same thing for the storefront. Here it's saying if it's multiplying the value of this times store rent times the number of months in summer, but we can do the same thing here, and we can say if B1 equals 1, F6 times F10, else it's 0. And the sign spinner works pretty much the same way. Even if you say you want a sign spinner, it's only allowing you to pay for the sign spinner if you have the storefront, because that just makes sense. So if and B1 equals 1 and B3 equals 1, then you are paying the spinner pay times the number of months, else you're paying 0. And finally, we have our cutting machine rental and our cutting machine depreciation. If we are renting our cutting machine equals B2 equals 1, then we should pay the rental price, else we should pay 0. And if we are buying our machine, it would be equals cutting machine equals buy. So if we're buying our machine, then we're paying the purchase price divided by the depreciation period is depreciation in each for the summer, else we're paying 0. So as you can see, that based on what decisions we make, if we decide we are going to buy the machine, it changes the decisions. And if we decide that we are or are not going to have the sign spinner, it changes our decisions. And if we choose our location, it changes the amount of money that we're paying as well. Now, all of these expenses together are totaled as our total expenses. Our difference between our gross profit, this should be net profit. The difference between our gross profit gross profit and our total expenses is our net profit. Our taxes are our net profit times the tax rate we decided on, and then our after-tax profit is the difference between our net profit and our taxes.